Peer-to-peer, or P2P, networking is a decentralized communication model where devices, called peers, share resources directly without relying on a central server. Unlike the traditional client-server architecture, where clients request services from a dedicated server, P2P networks distribute workloads among all participating nodes. Each peer can act as both a client and a server, enabling file sharing, content distribution, and collaborative computing. This model improves scalability, reduces costs, and increases fault tolerance. However, it also introduces challenges in security, resource discovery, and network management due to its decentralized nature. In a pure peer-to-peer architecture, users connect intermittently, and their IP addresses change each time they join the network. When a user searches for a file, the application locates peers that have the requested file. The user can then select a peer to download from, and the file transfer takes place using a specific protocol such as HTTP. File tracking in P2P networks can be managed in two ways: a centralized directory, where a server indexes file locations, or a fully distributed directory, where peers themselves share file availability without relying on a central authority. In a centralized P2P directory system, like Napster or Emule, peers inform a central server about the files they are sharing. When a peer wants to download a file, they query the central server, which returns a list of peers who have that file. The peer then downloads the file directly from one of those users. This system makes it easy to find files, but it also introduces a single point of failure. If the central server goes down, the system can't function. One of the main issues with a centralized P2P architecture is that the central server becomes a bottleneck. If the server fails, the entire network can be disrupted. In a fully distributed P2P directory, there is no central server. Instead, peers form an overlay network, connecting to a small number of nearby peers. The search for files is distributed across the network, with requests being forwarded from peer to peer. This system provides greater resilience and scalability, as there is no single point of failure. Examples include the Gnutella network. In a distributed P2P network, file searches are conducted by sending request messages that are broadcast across the overlay network. Each peer forwards the request to its neighbors, who continue forwarding the message until the file is found. Once the file is located, it is transferred from the peer with the file to the requesting peer using protocols like HTTP. To join a distributed P2P network, a new peer must first discover at least one existing peer. This process involves scanning a known list of tracker addresses and sending out a ping message. Peers that receive the ping respond with a pong message, indicating that they are available for connection. The new peer then connects to these responding peers and becomes part of the overlay network.